Hey everybody, welcome back to Vectors Conceptual Physics. Today we're going to be talking about mathematically adding vectors. This is similar to what we learned before with graphically adding vectors, if you guys remember that. However, instead of using a ruler and protractor, we're going to use our knowledge of math, Pythagorean theorem, SOHCAHTOA, and all of that to add vectors. So let's get to it. I would say this is probably the harder part of the chapter, but pretty important to be able to do well for future chapters. Okay, so let's look at this. There's a lot going on in this picture here, but let me kind of break things down. So what's happening here is there are three vectors. There's vector A plus vector B plus vector C, which is giving us vector D. Okay. So they kind of added it up graphically in this diagram. So let me kind of go through that. So we have vector A starting at this origin, going here, boom. And then we added vector B that starts where vector A ended, going some angle this way, boom. And then we have vector C, again going at some angle down here, boom. Okay. And vector D, let me change colors here. What vector D is doing is it's giving us the resultant vector, which is going from here to here. That is the resultant vector. Okay? And this is what it's showing us. But what it's doing now is it's telling us how we are able, let me do purple, to get the resultant vector. This is D, the resultant vector, also seen resultant vector seen like that. And what it's saying is D, what the resultant vector is in the x direction, is a combination of what A is in the x direction plus what B is in the x direction plus what C is in the x direction. And that gives us the resultant vector in the x direction when you add all of those up. Same thing with the y direction. So the y direction here, the resultant vector in the y direction is equal to A in the y direction plus B in the y direction plus C in the y direction. And when you add them all up, it gives you the resultant vector in the y direction. And if you combine this resultant vector in x and combine this resultant vector in the y, it'll give you the final resultant vector of A plus B plus C, and so on. Okay, so this is kind of like the theoretical formula, a theoretical way of getting this without any numbers. Okay, so let me kind of, and I know it's confusing. It makes more sense with the examples, but let me kind of break down this point. Okay, so how you want to do this is you want to break up each component, uh, break up each vector into x and y components. And let me just kind of show this in different colors. Let me do green this time. So break up each vector into x and y components. What does that mean? So as we can see, vector A here, we broke it up to find what A is in x and the A in the y. Same thing we did with B. We found B in the x and B in the y. So with every vector, we want to find what its x component is and its y component. That's the first step. Next step is add all of the x components together. This provides the x component of the resultant vector. So once we have ax, bx, cx, we add them all together to get the resultant vector in the x direction. Add up all the y. So same thing in the y. Once we have the component of y, ay, by, cy, we can find what the resultant vector is in the y direction. Then we use Pythagorean theorem to find the magnitude of the resultant vector. So when we know what the total x is, or the resultant in the x and the resultant in the y, now we can make this triangle here. This triangle is going to help us find what the resultant vector is, and we use the Pythagorean theorem to do that. We can consider this A, we consider this B, and we can consider this C, the resultant vector. And then we can use the inverse tan to find the angle. So we can find what this angle is now knowing what the resultant vector in the y and the resultant vector in the x is. Okay. Anyway, again, we're not using any numbers, so this could be confusing, but seeing the example should make sense. So let's move on with that. All right, so let's get started with this math example here. So first, what I like to do is I like to go through each vector and then just kind of add each one up. So we're doing vector A plus vector B plus vector C. So let's see what A is all about right now. So maybe I'll go up here. Okay. So vector A is 10 meters north. So I'm just going to draw a general vector A. Vector A is 10 meters north, so it's going to look something like this. I'm just going to draw A, 10 meters. Okay? Or maybe I'll just, yeah, okay, that's fine. And now what I'm going to do is I'm going to figure out how much is A in the X and how much is A in the Y. Luckily, I don't really have to do any math here. I can just do, maybe I'll put it down here. AX is equal to 0. And I know that because A is just going straight up. So it's not moving left or right at all. It's just going straight up. A sub Y is going to be positive 10. And I know that because it's going up. It's not going down at all. It's not going left to the right at all. So it's just going straight up 10. So I found A. Now let's do B. I'm going to use a different one. B is 7 meters east. So again, I'm going to just draw a general cross section here, and then I'm just going to draw how it looks. I'm not using a ruler or anything. I'm just like vaguely drawing it. Okay, good. And doing vector B is equal to 7 meters. And now again, I'm doing B sub X is going to be 7 because it's going 7 meters to the right. And I'll put positive. And then B sub Y is equal to 0 because it's not going up and down at all. Okay. And now let me use a different color. I'll do purple for C. So C is 4 meters south. So it should be looking something like this. Vector C equals 4 meters. And then the C sub X, again, C is not going to the left or to the right at all. So I'm just putting this at 0. And C sub Y is going down 4. So I'm putting negative 4 meters. And the reason why I have like these positive negatives is I'm going to say that's probably where most of the little mistakes come from, is knowing when to put positive and when to put negative. So when you put positive, it reminds you to look at like, oh, is it actually going to the right, or is it actually going up, or is it going the other way? And then you won't make that mistake. But who knows? Okay, the next thing that I'm going to do, maybe I'll do this in red, is I'm going to find, so that's the first step. If we look back, break up each vector into x and y components. Check. Next one is add up all the x components together. This provides the x component of the resultant vector. And add up all the y components together. This provides the y component of the vector. So let's do that. So I'm going to find the resultant vector in the x direction. And how we do that is, in this case, we have 3 vectors, a plus b plus c. So I'm going to do a sub x plus b sub x plus c sub x. If we had more vectors, we could just add more to it. But this is equal to a sub x is 0 plus b sub x, which is 7, plus c sub x, which is 0. So we get I'm going to do positive again, positive 7 meters. Now I'm going to try to find the resultant vector in the y direction. Same thing, we're going to do a sub y plus b sub y plus c sub y. So adding all the vectors in the y direction. So we have positive 10 plus 0 plus negative 4. Anyway, I like to just put everything as plus and then negative, but you could also just do minus 4, same thing. And then we get 6 meters. And I guess I'll put positive right there as well. Okay, so that's what we did. We found what the total is in the x and the y. And then if we go over here, we can use Pythagorean theorem to find the magnitude of the resultant vector. Okay, so I'm again going to draw a cross section here. And this goes 7 to the right. And then it goes 6 going up. Okay. And now maybe I'll do this dotted. This is going to give us the magnitude of my resultant vector. Okay, I'm just going to put R. And for R, the resultant vector, what I'm going to do now is I'm going to use Pythagorean theorem. So I should know that R is equal to, r squared is equal to 6 squared plus 7 squared. So I should know that r is equal to 6 squared plus 7 squared, the square root of that. Okay. Looking for my calculator. Great. So now I'm plugging this into my calculator. Square root of 6 squared plus 7 squared. And then I get 9.22. And that should make sense because the hypotenuse should be the biggest one. So 9.22 meters. But that is not my answer yet. Remember, when we're finding vectors, we also need the angle. So I need to find what this angle is. How am I going to find that angle? I'm going to use SOHCAHTOA to do that. So I'm going to do the inverse tan. Go all the way over here. Tan inverse is equal to opposite 6 over adjacent 7 is equal to theta. And honestly, I could use sine or cosine, but anyway, that's what I'm going to do. So theta, I'm going to put this into my calculator. Inverse tan is equal to opposite 6 divided by 7. And we get 40.6 degrees. And we can see that this is starting from all the way at the right, so we don't have to add or subtract anything. The angle is just 40.6 degrees. So the resultant vector is equal to 9.22 meters, 22 meters at 40.6 degrees. Okay, 9.22 meters at 40.6 degrees. Okay, next example here, example number 27. Mathematically add the following vectors. Okay, so same exact thing, different numbers. So again, if you didn't do this on your own, I would highly suggest doing it on your own first and then going through. Going to go through a little bit faster. So if you want more of an explanation, please look at the past video. So again, I'm going to do each vector at a time. Vector A is 5 meters south. So I'm going to do 5 meters. And then I'm finding what it is in the x and the y. Ax is 0 because it's not moving to the left or to right at all. Ay, it's going down 5 meters, so I'm just putting negative 5. And then I'm going to find b. B is 7 meters to the west. So it's going to look something like this. And then a sub x, that's going to be negative 7 meters because it's going directly to the left. A sub y is not moving up and down at all, so it's just going to be 0. And then I'm going to find the c. This is 4 meters south. So I'm going to draw that. C equals 4 meters. And the a sub, not the a sub x. Did that wrong. This is c sub x. C sub x is equal to 0 because it's just going up and down, not left or right at all. C sub y is going down 4, so I'm going to put negative 4 meters. And let me change this one in blue. A sub x over here, this should be b sub x and b sub y, so let me change that. And again, once we found the components broken into x and y, we have to add up the x's and add up the y's to find the resultant vector. Okay, let's move on. So now I'm going to find what the total is in the total in the x and the y. I'm going to use red. So again, the resultant vector is all of the x's and all of the y's combined. So there's going to be 0 plus negative 7 plus 0, which is going to be negative 7 meters. Yeah. And the resultant in the y direction, what's going to is negative 5 plus 0 plus negative 4. And this is going to be equal to negative 9 meters. So once I found what the resultant vector is in the x and the y, now I'm going to be using, now I'm going to kind of be drawing this out. Again, I'm going to make a cross section, and then this is going to look, okay, negative 7 centimeters, so I'm going to go down 7. And it doesn't matter if you start with the y or the x, but that's just how it is. So I'm just going to put 7. And then, whoops, I did that the wrong way. Sorry, making a few mistakes here. Okay, negative 7. going to the left 7, and then going down 9. Good. And the resultant vector is going to look like this. And we could do Pythagorean theorem for this. 7 squared plus 9 squared equals r squared. So I know r is equal to the square root of 7 squared plus 9 squared. So let me put that in my calculator. Square root of 7 squared plus 9 squared is equal to 11.4 meters. Again, that is not the answer. That's just the magnitude of the vector. We still have to find the direction. Okay, so direction here. I'm going to use tan to do that. So, and you can use sine, cosine, or tan in this way, but I'm going to use tan. Inverse of tan equals TOA, opposite, which is 9, divided by adjacent, which is 7. Okay, give me theta. Theta is equal to tan inverse 9 divided by 7, and we get 52.13 degrees. But remember, the actual angle is going to be all the way from this 0 point all the way over here. So how's that calculated? Well, we know this is 90 degrees, this is 180, and then we know this angle here that we just figured out was 52.13. So I'm just going to do 180 plus 52.13 is going to equal 232.13 degrees. Okay, so now I have my resultant vector is equal to 11.4 meters at 232.13 degrees. I hope that makes sense, and I hope that works for you. Moving on. All right, guys, so this is where it starts getting a little bit tough, and the reason why it gets a little bit tough is we're not just having south, east, north, west anymore. We're having things at an angle, which I'm not sure how much more difficult it becomes. It does become more difficult, but it definitely becomes harder. So, I mean, it definitely makes it a lot longer of a process. So, anyway, same thing. We're starting out with vector A and drawing it one at a time. So, doing a little cross section, vector A, 44 meters south. So, A sub x. Again, I'm not going to go into so much detail. Please look at the other video to go more in detail. So, what I did is in the x direction, it's not moving at all, or it's not going that way. In the y direction, it's going down 44, so I'm doing that. Next, let's look at B. So vector B is 21 meters east, so I'm just going to draw it like this. It should be technically a lot smaller, so let me just do it like that. 21, and then B sub x, it's moving to the right 21, so I'm just going to leave it like that. C sub x, B sub y is equal to 0 because it's not going up and down at all. Okay, and the last one, and this is, again, what makes it a bit tricky is this angle here, C. So we have C at 120 degrees. First, we have to kind of draw it out and see where is this actually going. So we should know that it's going to be looking something like this. Okay, not exactly, but anyway, that's what it should look like. C is equal to 32. And now we also want to find an angle. We could find this angle here, or actually this angle here, but I think it's more simple to find that top angle. It'll give us the same answers, but oops, sorry. So I'm just going to find that top angle. And what I should know is this over here is going to be 90 degrees when it's going straight up from this 0 point here. So that means if that's 90 and this whole thing over here is 120, that means this has to be 30 degrees. Okay, again, how do I know that? I know this whole thing is 120 degrees. And then I know directly up here is 90 degrees from here to here. So then I know that this has to be 30 degrees there. Okay, let me erase some things. Maybe I should also not go as fast. Okay. So now that I did that, I need to find what Cx is and what C sub y is, because the vector C has both. So I'm going to draw these dotted lines, and this is going to be C sub y, and then this dotted line, sorry, not exactly, but C sub x. So C sub x, this we're going to need to use SOHCAHTOA to figure this out, because we only have the hypotenuse and we don't have what the y component is or the x. So I'm just going to be doing, to find this, I'm going to be doing 32, which is the hypotenuse. And I guess I'll find x first. So I'm going to be doing, since this is the opposite sign, I'm going to do 32 times sine of 30. Anyway, if you need to do more of the manipulation stuff, take your time with this. But I know this is how to find the opposite side already. So I'm just going to be adding that. So 32 times sine of 30 is going to be giving me 16. Okay. And c sub y, this is going to, we're looking for the adjacent side here. So I'm going to use cosine to do that. 32 times cosine of 30. Let's see. And we should get 27.71. Okay. Oh, and I did kind of make a mistake here. What I should know is x is going to the left, so this should be negative. Okay. And that's, again, why I always usually put the plus and the positive or the negative, even though you don't have to put the positive, just to make sure you're doing things correctly. Okay, so now that we have all the components in the x and the y, now we're just going to try to find the resultant vector in the x and in the y. So the resultant vector is, we have 0 plus 21 plus negative 16. Now we should have positive 5, and this is meters. Okay. Resultant vector in y, we're adding everything to y. We have negative 44 plus 0 plus 27.1. Got my calculator, 44.1, we have 16.9. And that should be negative meters. Okay. Same thing now as we've been doing with the other one. Now we're just going to kind of like draw it all out. So draw out this resultant vector. So I'm going 5 to the right, and then 16.9 down. And then again, the resultant vector looks something like this. Okay, and again, I could use Pythagorean theorem to find out what this resultant vector is. So I could say 5 squared plus 16.9 squared equals r squared. So I know r is the square root of 5 squared plus 16.9 squared. And let's see what this gives us. Square root 5 squared plus 16.9 squared. And we get 17.62 meters. Okay, and now, again, just a vector. So vectors have both the magnitude and direction. So we need this direction. So I'm going to do inverse tan. Again, you can use sine or cosine, but I feel like tan is good. So I'm doing opposite, which is 16.9, TOA, 16.9, divided by adjacent, which is 5. And this will give me that theta. So let me put that in my calculator. Tan inverse equals opposite, 16.9, divided by adjacent, which is 5. And I get 73.52 degrees. Okay. However, again, remember, when we're trying to find the direction of this, we can't just say 73.52, because then we would assume it looks something like this, like that angle right there. So, and then, but what we want to do is we want to find the direction, which is all the way over here. So how do we do that? A few ways, but one way, and I would say the easiest way, is we know all the way around is 360 degrees. So if we did 360 minus 73.52, we could find what this is to get to this point right here. Okay, so that's what I'm going to do. 360 minus 73.52. 360 minus 73.52, and we get 286.48. degrees. Okay, so I hope that makes sense. The resultant vector is equal to 17.62 meters at 286.48 degrees. Okay, and all right, let's move on. Doing more problems like this. It takes a while, but let's keep going. Okay, similar kind of problem, adding three vectors here. Let's go through it one by one. Okay, vector A, 10 meters north. Step one, break it up into x and y components. X is 0, only moving up. Y is positive 10. And I'm going to start adding that positive, okay, to make sure I don't make mistakes. All right, B sub x is 7 meters at 30 degrees. Again, this is what makes it a little bit hard. Cross section here, 30 degrees, 7 meters. Oops, sorry. 30 degrees. We have B is equal to 7. And then we need to find what B sub x is equal to and B sub y. Again, we're using SOHCAHTOA to do this. I already know that, okay, I'm going to first look for the adjacent side. So I'm going to use cosine. So I'm going to do 7 times cosine of 30. I know that already gives me 3.5, but anyway, put in my calculator, because I'm too nervous. Sorry. It doesn't equal 3.5. The other side equals 3.5. All right, 6.06. 6.06 meters. And then B sub y is equal to 7. So this is the opposite side. So I'm using sine times sine of 30. And that's going to equal 3.5. But, put in my calculator because, you get nervous sometimes and don't know. But yeah, 3.5 meters. So that's B. And now let's look at C. 4 meters south. And then, so C sub x is equal to 0. C sub y is equal to negative 4. Okay. And that's it. We have all the x's and the y's. So now we're looking for the next step is adding everything up in the x and the y, finding the resultant vector. So in the x, we have 0 plus positive 6.006. And I really should be adding that positive there. Plus 0. And we get a total in the x of 6.06 meters. And then in the y direction, we have positive 10 plus, I should be adding that positive 3.5 plus negative 4. All right, 10 plus 3.5 minus 4 is going to be equal to 9.5 meters. Okay, now that we have this, again, we're putting everything into the x and y. Now we're going to be using Pythagorean theorem to combine both of these. So we have 6.06, and then we have 9.5. And the resultant vector is going to look something like this. Again, r squared is going to equal to 6.06 squared plus 9.5 squared. So find the square root of that. And let's see what we get. We get 11.27. Again, makes sense. It's the biggest number, and it's pretty close to the others. Meters. We again have to find this angle here. And luckily, this angle starts from the 0 degree angle. So that's all we're going to need to find. We don't have to add or subtract anything once we find that. So I'm personally going to be using tan to figure that out. TOA. So opposite, which is 9.5. Opposite of this angle is 9.5. And adjacent, which is 6.6. TOA. Opposite over adjacent, 6.06. And this equals theta. So let's see. Inverse tan 9.5 divided by 6.06. And we get 57.47. And again, we don't have to add or anything because this starts from that 0 degree mark. So I have the resultant vector is equal to 11.27 meters at 57.47 degrees. Okay. All right, let's move on. All right, I think this is kind of the last one with this. It is, I think, the most difficult, even though I have two vectors. So let's see how that works. Okay. So we have vector A here, 52 meters at 40 degrees. Let me kind of draw this out. 40 degrees is going to look something like this. A, 52 meters. Let me just do that. Okay, and this is 40 degrees. I know this is annoying, but I hope you guys are getting good practice. It is going to be important. All right, so I'm finding the a sub x first. And again, this is the adjacent side, so I know that's just going to be 52 times cosine of 40. So let's see, 52 times cosine of 40. And that's going to be 39.83 meters. Okay, and then this y side is the opposite, so a sub y is equal to 52, which is the hypotenuse, times sine of 40. $33.42 meters. And these are both positive. Okay, again, you don't have to add that, but again, I see so many mistakes with that, so I want to model that. And now let's find B. 38 at 300 degrees. So first, I want to kind of think generally about what quadrant that is, but here we go. 300 degrees. So again, this is 90, this is 180, this is 270. So 300 degrees is going to look something like this. Okay. I'm going to erase this 270 because it's just going to get in the way. But what I should know is, so this is B, 38 meters. And this y component and this x component, I should know that if that's 270 and we're looking for 300, this is going to be 30 degrees over here. Okay, so that's important to just do. So I'm doing that 300 minus that 270 to find this angle right here. Okay. All right. Now I can find what b sub y is and b sub x. So I should know b sub x is going to be, b sub x is an opposite. So I'm doing 38 times sine of 30. Okay, I know that's 19, but put it in my calculator anyway, because I have made mistakes before. 19 meters, and then b sub y is equal to 38, and this is on the adjacent side, so I'm going to use cosine. Cosine of 30, 8 times cosine of 30, 32.91 meters. And now that we've broken all the vectors into x and the y, I am going to, I'll use purple this time, to find the resultant vector in the x. So resultant vector in the x is a sub x, which is 39.83, plus b sub x, which is 19. Let's see, 39.83 plus 19. Oops. Okay, great. 58.83. And then r sub y, which is equal to 33.42 plus, and I made a little bit of a mistake here. This is going down. B sub y is going down. So this should be negative 32. And this is why I should always be adding that plus and that minus, because you might get it wrong. So plus negative 32.91. So let me do that. 32.42 minus 32.91. And you get negative 0.49. Both in meters. All right, and now let's kind of draw this out. What's going on here? Okay. So we first have 58.83, and then just 0.49. This is not proportional at all, but Just trying to make it obvious. Resultant vector here. Again, the resultant vector is equal to r squared is equal to 58.83 squared plus 0.49 squared. So r is equal to the square root of 58.83 squared plus 0.49 squared. I'm going to find the square root of that. Square root 58.83 squared plus 0.49 squared. Oh, sorry. Square root of 58.83 squared plus 0.49 squared. And then I get 58.83. And, honestly, that should make sense because this number is so low that the hypotenuse is slightly bigger, but it's essentially 58.83. Okay, so let's do that. 58.83. Oops, not degrees, that's meters. Okay, and then let's do we have to again find the angle here. So this is going to be a little weird as well, but let's just go through the math. That's the important thing. So inverse of 10 is going to be opposite, which is TOA, 0.49, divided by adjacent, which is 58.83. And this is going to give us a theta. Let's see. 0.49 divided by 58.83 of 0.48 degrees. And that makes sense because look, this number is so low compared to this side over here, so it's going to be a really low angle. And again, now we can't just put 0.48 because we're looking for this angle from all the way to the starting point to this over here. So to find that, multiple ways, but what we're going to do is 360 minus 0.48. And what should that give us? 360 minus 0.48. 359.52 degrees. Okay, so now that's what our resultant vector is. 58.83 meters, that's the magnitude at 359.52 degrees. Okay, so we get 58.83 meters at 359.52 degrees. All right, let's move on. All right, guys, let's start to look at some of these conceptual examples to get more of a feel and understanding of geometry and vectors and everything, so that this helps us with checking our work, and it also just helps us with knowing what we're doing and not just plugging in numbers. Okay, so look at the three sides of the triangle on the right. Order each side of the triangle from longest to shortest. So looking at these three sides, we have A, B, C. We might be able to be like, okay, they all have A, B, C. They don't have any numbers. How do we know which one's the longest and which one's the shortest? And you might think, okay, C is the longest. Well, because it's the hypotenuse. And the hypotenuse is always the longest when it comes to the three sides of the triangle. So you could say, okay, C is the longest. But B and A, how am I supposed to tell if B or A is longer? And the key for that is looking at this angle here. So looking at that angle, we should be able to figure out more of which one is longer. And we should know that if for example, if the angle is like 45 degrees, they're going to be, B and A would be exactly the same. However, if it's less than 45 degrees, like this one is, that means that B is going to be less than A. Okay? If it's more than 45 degrees, then B is going to be more than A. Anyway, I know that's a little bit confusing, but let's pull it back a little bit. And what we should know is it's 30 degrees, so that means it's less than 45 degrees. So that means B is going to be less and A is going to be more. So it's going to be C, A, B. Cab. Okay. Okay, let's look at the next one. Similar kind of question here. I'm not going to explain it as much, so if you want more of an explanation, please look at the next one. Last one. Look at the three sides of the triangle. Order each of the triangle from longest to shortest. Again, we should know that C is the hypotenuse, so that is going to be the longest. Again, we should be looking at this angle to figure out which one is bigger, A or B. And since this is a 50-degree angle. Remember, a right angle is 90 degrees. So this is more on this side than it is on this side. That means that B is going to be larger than A. So it's going to be C, B, A in this instance. Okay. Again, look at example number 2 for more of an explanation if you got confused. Look at these three sides of the triangle. Order each of the triangles from longest to shortest. Again, if you've been watching this so far, you should know the hypotenuse is always just going to be first, which is great. And this angle here is what's going to help us to know which leg is bigger. 65 degrees means B, it's more than 45, so B is going to be larger. And A is going to be shorter because since most of the triangle is on this side of the 90-degree angle, that means B is bigger. So it's going to CBA. Okay. Okay, look at the side of the triangle on the right. What would theta be looking at the information that is provided to you? Okay, so we're looking for what this theta is, or just like a general guess of what theta is. So if this side is 50 miles and this side is 22 miles, we can see that this is bigger than this. So this is bigger than this. So if this side is bigger, that should tell us that this angle here has to be more than 45 degrees. Okay, because if it was 45, they should be exactly the same. However, if this is more than 45, this needs to be bigger than this. So it should be greater than 45 degrees. Okay. Look at this one. Look at the side of the triangle on the right. What would be theta? What would theta be looking at the information that is provided? Again, we are looking at this. Again, this side is more than this side over here, so this should be more than 45 degrees. Okay, same thing. Next example, what would theta be looking at the information that's provided to you? So we have theta here. And remember, this adjacent side is more than the opposite side. So that means that this is going to shrink. So this 45 degree, this is less than a 45 degree angle because most of the vector is on this side. Again, if that didn't make sense, look at the other ones where I explain a little bit more before this problem. Okay, less than 45. Okay, let's look at this. Looking at the sides of the triangle on the right, what would theta be looking at the information that's provided to you? So again, we have more on this side. And if we have more on that side, that means this has to be a shorter angle over here. So, and not as much on this side. So 52 is bigger. So that means that most, even though I know like this one looks weird because like, why is this so long if this one is shorter? And that could be confusing, but if you look at the numbers, we know that this one should be longer. And if it should be longer, it should be looking more like this because most of it is on this side. Well, only a little bit is on this side. So this should be less than 45. Okay. Okay, moving on. Look at the side of the triangle on the right. What would theta be looking at the information that is provided to you? Oh, so again, now this one's a little different. We see that they are exactly the same. And if the lengths are exactly the same, that means this has to be a 45 degree angle. Okay. Look at the side. What would theta be looking at? Again, this one is more. I've done so many of these. I don't want to talk too much about this. So this has to be less than 45 degrees. Again, look at the other examples if that was confusing. All right, and that's it for this part. Now we're going to be talking about a part of this chapter that I really like, actually a part of all of physics that I really love, which is talking about relativity. So I'm really excited to teach and talk about that, and I hope I'll see you with the next one. Thanks for watching, everyone.